increase the font a little bit?
Increase?
Yeah, Control plus.
Yeah, I did. Hold on.
Yeah, much better.
Is it clear? Okay.
Yeah, yeah.
I think this is font 28 already.
Yeah.
Can you remove that one, the black one, window,
So I'm
small
going to
on the left?
unshare now. What else do I need to see?
No, that small window, the black one.
At the right hand side, you can see the Teams window also popping up, right?
The Teams window on the... Actually, I'm running a Linux version, so I don't know what you see.
Okay, can you share once again?
When I share, this thing goes into the background.
Okay,
Yeah,
because
if
you
I
see
click on...
a window like a pop-up, like a small box, which is a Teams window, and you can just click on that, and Teams will go and sit in your taskbar.
I don't know. Let me try again. I see there's something here. Uh, do you see the screen now?
Yeah, I can see the screen. Yeah, the same
This
one.
is
You
not...
see that white line kind of thing, right? A small white
Yeah,
thing. Yeah, just click that. It will
it
minimize.
hides.
Yeah.
Yeah, okay. 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 And what is this? Oh, so now you see yourself.
Yes. Picture in picture.
Yeah. So I will unshare. There you go.
Okay.
You know, this is better than what we're using in the office.
We are using link, right?
Yeah, Skype. It sucks.
Yeah. Skype.
So slow. I
That's
swear to
anyway
God.
going away.
Sorry?
Uh, they are going to replace that with Teams soon.
Oh, really? Teams will
Yeah.
replace Skype?
Yeah.
Oh.
I think slowly that's the way. I will just try to change my background if I can. I don't want to see all the.
You know what? There's nothing that of that kind here. In it's not available in the Linux version. I hate it.
Okay. I think it depends on your this one, the version of Teams.
Windows, Mac, yes, not Ubuntu. I hate it.
Dingin nggak?
But it works. Why not?
I don't have that option of changing the background.
Huh?
It's okay.
Really? You should have.
Yeah,
You're using Mac, or I saw it from the website that it's only offered for Windows or Mac. You know,
yeah, yeah.
the bottom...
I think I need to log in. I'm logged in using like an anonymous user, so it's not giving me that option.
Oh, now I can mute too. Yeah. Why there are many reboot?
Reboot is what you say, replicating himself.
Yeah, it's like a Matrix.
He logged in from two devices, is it, Reboot? He's on mute. Okay, I'll start sending some tweets.
Wow, what a work.
Yeah, I can see your screen, Bal. Thanks.
Alrighty.
So let's wait for maybe another 2-3 minutes, and then we can get started.
Okay.
Okay, let's get started. So, thanks, guys, those of you who have joined. I see that many people are from Credit Agricole. So, I think it's the Balthazar effect that we have so many people joining for today's session. So, today we have got two topics. First one is external scalars with KEDA, which Balthazar would be presenting. And then we have Andri Yadi, who is from Indonesia. He is a Microsoft MVP. He'll be talking about how to fight COVID-19 with Azure IoT. So I hope you find these two topics interesting. Let me start quickly by introducing Bal. So those of you who don't know Bal, he is out and out geek. He's a Java expert. He is fond of open source software, and he contributes quite a lot to the open source projects. There are very few people in my circle whom I know are active contributors to the open source software. We all like to use software, but we hardly have time to go back and contribute. But Bal is one of those lucky guys who is able to contribute, and he has been contributing to open source projects like KEDA and MicroKTS. So without any further ado, I would hand it over to Bal and let him take over.
Thank you, Nilesh. So everyone can see me. Can you see me?
Yep, I can see you. I can see your screen as
All
well.
right. So, guys, thank you for joining in. Tonight we'll talk about KEDA, and how you can extend KEDA without getting into KEDA. So as part of this demo, I'll do a external scaler that uses ActiveMQ, and we know that ActiveMQ is in Java, so it's not there in the current scaler. So, all right. So a little bit about me. I work at Credit Agricole, CIB Singapore. I work as a technical architect there. So as Nilesh has mentioned, I'm an avid fan of open source. I really like tech, cool tech especially. I do Java by trade, and I'm going ballistic with Golang, so it's kind of cool. On my free time, I do contribute to MicroK8s, which is a ops free Kubernetes distro. It's free. You can run it on any almost any Linux distro. And also I do contribute to KEDA occasionally if I get my chance. So if you want to head up through GitHub, so I have my GitHub link there. I do have some projects there that I try to play with. Okay, so let's go. So what is KEDA? KEDA is a Kubernetes native event-driven autoscaling as it is. Kubernetes on its own have this what they call the autoscalers, such as horizontal pod autoscaler or vertical pod autoscaler. So what exactly do these things do? So what they actually does is based on certain metrics or certain numbers, it can scale up or down certain deployments or your pods. So that's mostly what the horizontal pod autoscaler does. But what it cannot do today is to scale from zero, meaning there's nothing running, to a number. So if you look at the architecture of KEDA, so it actually relies on the horizontal pod autoscaler, or HPA as they call it. So they provide the metrics to HPA, which will then scale it up or down, so depending on the need. And another thing that KEDA does is that it handles the scale from 0 or to 0. So it's actually a simple it's a simple system. If you look at it, it only has two pods running. So one is the metrics adapter and the operators, and that's it. So that's KEDA for you. And what do we have in KEDA? So KEDA has all these scalars. What are these scalars? So these scalars are actually codes that understands the protocol of these brokers. For example, Kafka. We have it does also, it talks to Amazon CloudWatch. We also have Azure Event Bus. We have Postgre. So what they do is that it can query certain tables, and depending on some results, it can either scale up or scale down pods. There's more. It has Prometheus. It talks to Prometheus. It gets figures from there, metrics, and it feeds off the HPA. As you can see here, we don't have any JMS based system here or brokers. So what we're going to do is that we're going to extend the KEDA so that it knows how to do that. Okay, so that's so. So if you want to add, which is great, if you want to add scalars into KEDA, you can head up to KEDA core /KEDA in GitHub, So you can add all these scalars in there. You pretty much have to write it in Go and all this. So and you have to wait for the next version of KEDA before you can have it. So it takes some time around that, and also sometimes you have specific information system that you have that is only relevant to your organization. Let's say you have a file watcher kind of thing. So if you have this, let's say if you reach X amount of files, you want your process to read more files, or you spin more process so that they can read more files in parallel. So these can be very specific to your needs. So you can extend without waiting for KEDA to release a new version. Okay, so that's so in this slide. So this is an external scalar. So you can KEDA will talk to you, and so you will gather all those metrics, and these metrics you will feed off to KEDA, and which eventually will end up as a metrics to the horizontal pod autoscaler. So they're out of three, meaning you can write it into your own repo. So you can even have it on your own internal repository, your company repository, things like that. And it doesn't change the KEDA. And yes, you can really tailor it for your needs. So so how does it actually work? It's actually also simple. So inside KEDA, there's an external scalar on top of all those other scalars that I show you. So the external scalar is a client of your scalar. So it will query your scalar for X amount of time. You will feed that scalar every time it calls you. You give numbers to it, and that's it. So for your custom scalar, you can actually do a lot of things. It's really up to you. As I mentioned, you can say, for example, let's say you want to monitor your own custom broker file system is one thing. So this is how they talk through gRPC. And what exactly is gRPC? So gRPC is actually kind of like a remote procedure calls that is high performance. Why is it high performance? Because it uses HTTP2, so you get all the goodies of HTTP2, such as automatic header compression. You also get the client-side streaming. You get server-side streaming. You get bi-directional streaming, and the most common one, which is the unary calls, which is the ubiquitous request and response. So gRPC supports load balancing in a way that it doesn't hinder any load balancing. But traditionally, unlike an HTTP 1.1, where it's you have limited connections that you can use, gRPC tends to be more stateful. So once you're connected, it's more or less you get connected to that. So well, the good thing is that you don't the cost of connecting and disconnecting is reduced, and it can also multiplex requests. So if two clients can share the same connection, and it knows how to parse them. So gRPC, as any RPC, do have code generators like stubs. So it generates stubs, and these stub generations are available on multiple languages. Java, of course. We have Go. .NET Core has native support for it now from 3.1 or 3.0. Can't remember, but it's native now. It's not like it calls a C program, so it's really part of .NET Core. There's Python, there's JavaScript. Yeah, so there's plenty of programming language to choose from. There's also C. So yeah, and one thing that also differs from the traditional REST, if you want to compare that with REST, is that REST is or any the SOAP service, they are very textual. That means everything that the transfers from client to server and back are all represented as text. Text can be very verbose. Let's take, for example, number. One representation of one is different from a representation of a million. So the number of bytes grow as you increase the number of characters. But for that's where protocol buffers comes in. It's a binary. It's binary. So you define if it's integer. So even if it's a million, then it's always 8 bytes. And it does provide you backward compatibility, meaning if the client tries to send the data to your server and your server doesn't understand any of those, it will just ignore. So it won't choke on you. So that's by default. Protocol buffers do bring you. So yeah. So as a quick glance, gRPC has a proto definition because it will generate codes for you for most of the programming languages. So it generates this code. So we define what we want to have in the proto definition. You can look at this as WSDL if you're into SOAP, or I won't call it Swagger, but yeah, it's like a contract that, okay, I give you this. If I give you this file, you should know how to talk to me as a client. So let's say I'm the server. You know how to talk to me. So this is what I give you as a contract. Then you do. So as you can actually see, the formatting is a little bit off here, but it does have fields. So so everything that has a message, prefix message, those are the actual message that you send. So these are data that you send to the server and back. And these service on top here are the functions, service methods that you want to call. Okay, so you can definitely see from here that, for example, the new service accepts a new request object, which if we go here, or a request message, a new request message. So these are the fields that you will have to put before you call the new function or the new service. And it returns empty. It's like void. So you need to tell that, okay, it returns nothing, so it's empty. And is active, same thing for is active. Send you a scale object ref, and then I will return an is active response. So as you can see, there's really no Boolean, no primitives here. So they're all messages. So if you want to represent, you want to return a Boolean or something primitive, it's best to wrap it as a message, so you can extend it later on. So these are all the kind of things that you will see on a gRPC. Okay, so for the demo, what will I do? So I have this KEDA cluster here, so I expand it a little bit, and it will talk to my metrics provider, which I call the Artemis metrics provider. So just a little bit of information around ActiveMQ Artemis. ActiveMQ Artemis is the next generation of ActiveMQ. The ActiveMQ 5, which they now call it the Classic, and this is the ActiveMQ Artemis. Artemis is based off Hornet Q back in JBoss days, and it has been contributed to Apache and became part of the ActiveMQ umbrella. So you still have the ActiveMQ5, which now they call Classic. So in this, so I will this time I will talk to ActiveMQ Artemis and not the Classic. So how do I talk to it? I will talk to its management endpoint. Artemis provides some ways that you can monitor the broker. You can see how many messages you have, then how many consumers or how many producers connecting to it. So these are all available through what they call Jolokia. Jolokia is basically a sort of like an agent that you attach to a Java process, and it can read your MBeats, your management Java management beats, and then it will expose it as a REST endpoint. So it's how we can connect to it without actually using direct APIs of ActiveMQ. And so once this metrics provider queries the management endpoint for the number of messages, so what we're going to do here is that I'm going to monitor the number of messages that is coming, that is in the broker, and then I will tell KEDA, okay, this is the number of messages that we have at this point, and based on certain rules, it will either scale it or scale down. So the thing is, I'm recently going ballistic, as I told you, on Go. So Artemis metrics provider is actually written in Go. I will show you how that looks like. But again, it's for sure you can write it in Java or .NET. So once you have that, so KEDA will take care of scaling the pods as based on the KEDA or HPA. Then they will start to consume in parallel. So I also have the producer here, which is a normal Java Spring Boot producer. I purposely put it outside the cluster so I can control when I run it or when I don't. Okay, so I will jump now to install the metrics provider along with the ActiveMQ. All right. Oops, sorry. So just to let you know that I have a 4-worker node of micro-K8s running in Azure. So why 4? I don't know. It sounds like a good number to me. And so right now, if I check, so you'll see I only have a KEDA operator running, the metrics adapter and the operator, and of course the coordinates. There's nothing else. So we're gonna install the metrics provider. Okay, so I hope you can see my screen. Okay, so how am I going to do that? So I use Scaffold most of the time to do my dev. So Scaffold helps me build my image and deploy it at the same time. So if you want to see, this is how it looks like, the Scaffold file. There. So I tell Scaffold what you want to build, what image, where is the source code, or if you're using Docker file, where is the Docker file. You can have many kinds of builders. So this one is I'm using a Canico, which is an in-cluster build, meaning it doesn't use my local Docker to build. And yeah, so the cache is where it checks whether is there something already built like that. If it is, then I won't have to build, and I will just finish that, so it doesn't build. And if you have some secrets that you need to push to your Docker registry, then you have to put it here, telling him where to pick it up. And so it's build, and after that you deploy. So when you deploy, you can use kubectl, which is there, or it supports Helm. It also supports customize. Yeah, that's mostly it. So that's what I'm going to do. So I have two kinds of profiles here in Scaffold. So if I do it locally, I use this one. But if I want to do it a cluster outside my machine, so I use this profile. So this is what I'm going to do right now. So I type, what is that? Sorry, metrics provider. Okay, so let's make this big. So let's see what is happening. Okay, so what it does is it's actually checking the cache. So since I built this already, so it goes to Docker Hub. So I have my stuff in Docker Hub. This is the tag. So by default, Scaffold uses the Git hash, so you won't have collisions. So it's checking Docker Hub, and hopefully it comes back and say it's not there. It's not going to build. It does take some time. This work. It's taking time. So it's actually best if you have your local registry just beside you if you're going to do this. So if you're going to run this with some registry that you don't know whether it's nearby or some 1,000 kilometers away. So it did found the cache, so it didn't rebuild it, so it just used it, and then it started to deploy all the things that I need, which I can also show you. So it comes here, and maybe my screen is too big. I'm so sorry. So what do we have here? Yeah, so the secret to access ActiveMQ. That's nothing fancy there. And the service, so that different pods can actually talk to it. Oh, so yeah, you need to export this one too if you want to get to it. And you will see that I have gRPC, and I will tell you why. ActiveMQ doesn't speak gRPC, by the way. So this is the config map, which I customize some configurations of ActiveMQ. So it automatically creates a queue named test, and which address, they call it the address. So with this, when you start your ActiveMQ, it will automatically create it for you. And now we go to the deployment. What is a deployment? So so I packed the ActiveMQ and my metrics provider in one deployment. So meaning I have one pod with 2 containers running. So this is the usual one, which is as you can see, it's not mine, it's somebody. So I just took it from V Romero. So ActiveMQ Artemis 2.6.2. Maybe there's something newer out there. And this is mine. So this is my metrics provider. So I'm deploying it, and I just decided to just put them together. It's easier for me, but it doesn't have to be that way. Okay, so I deploy that on port 5050. That's also the reason why you see that I have a gRPC port here. I hope I'm not moving too fast. So that's 50/50. It's because I'm using it. And that's also how KEDA will talk to me through that port. Yeah, and the usual suspects like the username, password, and the pod name. So actually, the pod name is really to tell how do I tell KEDA that I'm unique. So I just added something, broker. And my request and CPU limit, the usual ones. Yeah, so that's it. Oh, by the way, the one I showed you earlier, I'm sorry, it's actually a init container. So it creates these files so that when ActiveMQ starts, it has all those configurations that it can see. And this is where the Artemis image goes, and you will see that it's also mounting that volume, all these two. So that's it. So let's check first how it looks like. Let's do this. You know what? I'll show you another tool that I use called Octane. So this is Octane. It's if you don't want to do a command line, you can use Octane. You can download Octane from Octane. So you can so I'll show you Artemis. I'll check the workloads. Are we running? Yes, it says it's running. There are 2 containers in the pod. Let's drill down. Okay, so what are the containers? So this is the ActiveMQ, and this is me, the metrics provider. So they're all running. The good thing here in this Octane, if you're running it locally, you can port forward, so you can immediately you will see that, which we will do right now. Let's try it. I'm gonna port forward, and I want to connect to ActiveMQ. So I'm gonna start this one. Let's see if I can connect. There you go. Oh, it doesn't want me to click. There you go. Okay, so user Artemis, password. Please don't do this at home. It's another Artemis. Oh. Yeah, I know. So as you can see, we will have the test queue. Sorry, I have to. And if I go to the browse, that means I have nothing there right now. Okay, so we know that there's nothing there. And now I'm going to show you the code of the metrics provider and how it, well, this is in Go, but you see the point. So in a Go program, it's like C or Java, you have the main. So in the main, I actually start, so I get all these options or arguments, and then I print them. And I start a gRPC server. This is very standard in a gRPC for Go. So you create a new gRPC server, and you register if you want to do reflection on it. So you just register it, and then later you just pass the server, which has the options of the ports, etc., and the new server, and you serve. So what is the new server? So let's go find out. So if you look at the new server, it's actually just returning something, a struct, actually. And so the struct will come with the implementation. Let's go up. What does this guy look like? So it's a struct. okay, with the scaled object, and that's it. Because it's given to me by the proto buff. The when I generated the proto file, maybe I have it here. Where is my proto file? Okay, yeah, you're right. So I have this proto file. You can get this from the KEDA source. So this is how they will talk to you. And after you run the proto compile, it will turn it to this is generated by Protalk, Protalk Gen Go. So it generates this, and you can start using this as part of your code. So the server.go earlier, it's actually referring to that here, right here. Okay. So what does it do? How does Go knows that what to call when there's really no extending something? Go actually uses I don't know if it's the right term, but it's called like duck typing, where if it sounds or if it talks like a duck, if it walks like a duck, if it walks like a duck, then it must be a duck. So that's it. So if I have new, so this I implement a new, then that means that anyone who wants to use me has this signature, they can use it. So it's a bit different from how Java, where we have to implement an interface and it has to be that construct. But in here in Go, it doesn't work like that. It doesn't have to be like that. So new. So what does a new do? New actually is called for every poll. So KEDA will check you all the time. So don't think that it's instantiated once. So I got burned by it. So it will always call this new, and it's just to pass you certain metadata that you will put in your scalar. So just remember that this is not a new that doesn't have that is instantiated once. So it's called very often. That's new. That's the first thing we'll do. And close after it done all that cycle. So it will call new. Then it will call the metric spec. The metric spec is actually returning the scaled object that will be that will tell HPA, okay, this is the metric name, and these are the target sizes that I have. Say I have a maximum of 30 pods that I want to scale up, and the minimum. Okay, that's a spec, just a spec. And then this is an internal function. It's small letter, that's why it's in private. And this is the other one. So this is also called for every poll, every KEDA poll. So it's a metric. So basically, I return a metric type, which has a value. In my case, I will return the number of messages in the queue, and KEDA will do the rest. So that's about it. And then, so what do we do now? So now that we have this, I need to pump message there. So I'll also start the port forward so I can run my, remember I have a producer outside which will pump message to this. So I'm gonna start it. No, I won't do that. I'll probably, yeah, okay, I'll do it. 42333. Okay, so I'm gonna do is I'm gonna go to my producer program, which is again a very simple Java program, which is just sending a message. But before that, I'll change my port. 42333. All right, and because I'm using Spring Boot, I'll just go to that. Can I move you away? Okay. Yeah, sorry for that. It has to run a bit of some stuff. So it's actually sending right now. All right, it's 1,000 messages that I send. So let's go back to the Artemis page. So now you can see that I have these many messages. I have 681. Maybe I can zoom this out. Okay. Right, so I refresh this one. So I have 1,000 messages. Okay. So I now this time around I will start to run my I will deploy my consumer, which is going to run in. It has to be inside Kubernetes, so I'm going to do that now. So I'm using scaffold again. It's a Java program. Bam. So for consumer, if you would like to know, I'm actually using Jib to build the Java program. Jib is cool. It doesn't require you to have a Docker instance running. So it creates an OCI compatible image. If you're not going to use the Docker daemon for dev, or let's say you don't have, it will create an image either in a tar or directly pushing to a registry. In my case, I am directly pushing to the registry. So again, Scaffold will find the cache, and if it exists, it won't do the build. All right, so it should be deployed now. Let's check. Let's check Octant. Let's go back once. Yeah, so it hasn't started. It's still in red. Let's wait. Should be there in a short while. So while we're waiting, I'll show you what the KEDA scalar CRD looks like. So how do I tell KEDA what it should do when it finds these many messages? So KEDA has a very short manifest. You just tell him. So the kind is a scaled object. You give it a name. This is something that many people forget to do, is that the deployment name and the scaled target ref. So both of them have to exist and they have to be the same. But what does it mean? So if conditions apply, it will apply it on this deployment. So it will scale this deployment. So that means you will see more pods or less pods. Polling interval. Remember when I mentioned that KEDA polls your external scalar? So it's actually this interval. So every 30 seconds, it will check for metrics. It will call the new, it will call the get metric spec, and it will call the get metrics. And also is active. Again, I forgot to say that. So what does is active do? Is active is actually the one handling the scaling from 0 to 1 or 1 to 0. HPA today, maybe not today, because it starts to have support for scale from and to 0, but previously it doesn't have. So it's actually KEDA is going to do that. So that's the role of the isActive method. IsActive. There you go. So the code says if my message is greater than 0, that means I have something, otherwise nothing. So it's a boolean. So let's go back here. Cooldown. So how long does it wait before it scales to 0? Okay. You will notice that I put like 600 here because it's a. Why does it take that long? Because if what I want to show you is that the HPA also does it for you, but only up to the 1. So if I put something lower than the default HPA cooldown period is 5 minutes. So if I put it before 5 minutes, so I'll never see HPA cool it down in this case. And the minimum replica, I want it to be 0. And the max replica is 30. So I can go all the way to 30. That's it. That's my limit. And if I now I know why there is no pod, because when I deploy this this consumer, I purposely mentioned that it should be a 0. So there's no pod, should have no pod. So next step, we're gonna apply this external scaler and see it in action. Bam. Okay, so it's applied. Let's go back to Okta. We can go check if the horizontal pod autoscaler, it's here. So you will see that the minimum replica, because that's a default today, which is 1, and the max replica of 30. And you will start to see, as the more I give metrics to it, like it starts to query, to check Artemis, how many messages in the queue. Then you will start to see that it starts growing. I have 4, and followed by I wanted 8. So in a short while, it will become 8. And once we can also see that the workload, the pods will start to grow. So you see, I have many consumers running now. How many are they? Probably 17 or 16. And let's review. Let's check how many messages are being consumed. So I only have 534. So now I have 30. Shucks, I tried to make this bigger. So I have 31 pods running, including the ActiveMQ. So I go max, that's it, 30. And I think this one's done. So there's no more item. So usually if I leave it at that, it should, it starts to check my is active. So it starts to check is active method every poll, and it starts counting down. It starts counting down until it satisfies the cooldown period. Then it will try to scale everyone back to 0. Okay, but because it's 10 minutes, and if we have a bit more time, you will see that it's not scaling down. We will wait for the HPA to do, which is 5 minutes. So during this time, you will see that it's not really scaling down. Because why does Kubernetes decided that it's 5 minutes? Because you don't want to have you don't want to be too aggressive when scaling down. You also need, because when scaling down, you might want to address the in-flight messages. So these are also not so easy to tackle. There are ways to do it, such as a shutdown hook, things like that. So you start consuming, you stop consuming, sorry. But still, you can't be too aggressive. Otherwise, it does add a bit of load on the node. They just come and go, pops up and come and go. But what is really important here is that when there's really no load for a prolonged period of time, you don't have any process running. So if you're in the cloud, and you can actually perhaps save a lot of money on that. All right, I think yeah, it takes some time to do. So that's mostly it. What else am I missing here? That's it. You can wait for it. Maybe while we wait, I can answer questions if you have.
Well, one question.
Yes.
What was the name of the tool you said you can use to build OCI compliant images without having the Docker daemon running?
It's Jib. Let's go check it out here right now. So this one, it's for Java. It's Maven based. I
Okay.
use it a lot, and I like it. Oh, Gradle, it does support Gradle. So if you're using Gradle or Maven, you can use
So how is this different from something like Quarkus?
it. Quarkus doesn't grade the image. I'm talking about the Docker image. It's not Quarkus turns your Java program to a native binary. Either it's in Linux or in Windows. So Jib does just turn it into package it into an image. I mean a container image.
Okay, thanks. Thanks for that.
So I hope we are. I hope it's done. No, not yet. 5 minutes is too long. Ah, there you go. It starts terminating them. So there you go. So you will see it's some of them are being terminated, I guess. So it used to be 28. So now it's 28. It starts to go down 25. I hope you can see it. So the HPA starts to kick in. It starts to scale it down after some 5 minutes. So you will, oh, now it's great. It's just one left. And I'm not going to wait for KEDA to scale it to 0. It's 10 minutes, but we can if we have. So that's it. Have questions? You can ask. So sorry, forgot to tell you that these are my references. So all the source code for this external scaler is in Artemis ext scaler. If you want to get info on KEDA is here, Apache ActiveMQ scaffold. So this is really a good read around the horizontal pod autoscale in Kubernetes and microcakes. My friendly microcakes. That's it.
Well, since you are also a contributor to MicroKTS, can you talk a bit about that? What is it and how do you use it?
Okay. So maybe I should just go. Okay, we have time. Okay, so it's a certified Kubernetes distribution. What So it's like a Minikube, but it's not by Minikube. So Minikube starts, for example, starts a VM, though it supports a VM, not no VM. But usually we use you want to start a node, a Kubernetes node, so everything is packed in. What it does is that microcates, if you run it on Linux, it doesn't start a VM. So everything is packaged as a snap package, meaning all the dependencies are in snap. So if you have a different open SSL outside, it won't interfere with it. Because in Linux, once you have it in your LD library path, things gets haywire. So this is what snap tries to address. And when you remove that snap, it's all gone. It throws away everything. So microcate is done like that. So you just install microcate using snap, and you have your single node. It also supports multi-node. So in my case, I was I was running it. So it's actually very simple. If you go down here, so if you install snap, you just do a snap install microcates or classic, which is the so classic is a way for snap to say that you can have access to certain file systems, things like that. So it's a bit more like apt-get. It's not very strict. The default is called the strict mode. And then that's it. Just one command, it will download microcates and you will start it, and you have a Kubernetes cluster. Yes. And what good does it have? It has add-ons. You have the dashboard. You have the DNS add-on registry. The one that I contributed was Linkerd. It also has Istio. So you just do enable Istio or enable if you want a load balancer, for example, which is really cool. Metal LB. So you just microcates enable Metal LB, and you have a load balancer like the cloud, all in your laptop. It has Windows, so it needs Hyper-V, and Mac OS, perhaps HyperKit. Check it out. It's actually really cool. It's easy to use.
Yeah, looks really cool. Thanks for sharing that, Bal. Any other question from the attendees?
Hello. Actually, I have just more a fundamental question on this autoscaler and actually how it triggers more pods. So actually, it's similar to the CloudWatch in AWS, I guess. I mean, it treats the metrics and then react. Accordingly to the load. Just this one is it's a more custom, depending on, I guess, like a specific metrics than we depending on our applications.
Yes, so you can have metrics according to your needs. That's for the external scaler, but KEDA in general is actually for event driven. And when you run in Kubernetes, I think you can run on any cloud as long as you have the Kubernetes in there. So it's more, I would say, generic, but more for event driven. That's all. Something that it can't do, which on its own, is that HTTP events, like request, which is really hard. If let's say your pod is 0 and there's no request going in, there's no way for you to capture those. So it's really hard. Usually what people do is that they have one pod running, and then they can start capturing the requests, and then they can scale up, but they cannot scale to 0. And yeah, that's pretty hard.
But actually, this is how do you implemented this the is active method. I mean, that checks where. Right?
Yeah, it's actually really simple. So how do I talk to first? Maybe how do I talk to ActiveMQ? Is just a normal get HTTP get. So is active is nothing more than I just check how many messages I have. If it's greater than 0, that means I'm still active. That means if the number of messages are more than 0, it's still active. If it's 0 or less, 0, then it's not active. That's where the cooldown period starts to count down.
I mean, what I wanted to say, I mean, for the case of, let's say, HTTP, as I said, it's a kind of a limitation.
Yeah.
It will be to implement, I mean, the same way, but yes, I mean, it's a bit more complicated.
Request. So for HTTP, we actually you can rely on Prometheus to capture those. So that's what people do if they want to use HTTP based scaling. They use Prometheus, which gathers all these metrics for you, and then you query Prometheus.
Okay, perfect. Thank you.
Okay, thanks, Yusuf, for asking that question. So I think we are right on the dot. Bal, do you have anything else to share with the attendees?
No, it's just that, KEDA just scaled it to 0 right now.
Okay.
You can see. That's it.
There is
Thanks, Bal.
one question from the online viewer. Can Micro X run on cluster?
Yeah, it does support the multi-node, not HA control plane yet. Like I do right now. So if I open this one, I have the number of nodes. So I have this many nodes. I have the controller. I have the 3 worker nodes. So yeah, it does support the multi-worker nodes, and upcoming will be a multi-controller like HA. It will be still in beta.
All right, thank you.
Thanks, Bal. So I think we are right on the dot. Since we started a couple of minutes late, we have a wonderful session with you, Bal. Thank you. Thanks for taking time and sharing this, your own contribution and a wonderful demo as well. Now let's move on to the second speaker for the day. It's our MVP from Indonesia, a special guest. His name is Andri Yadi. He's the CEO of Indonesia's leading Azure IoT enabler, and it's named as Dicode X. He's also a self-taught entrepreneur for more than a decade and a half. So I would like to hand it over to Andri if you're ready. Can you share your screen, Andri?
Andri, maybe you're not audible.
Hello, you're able to hear us, Andri? I think you're on mute. Hello, hi Andri.
Hello. So can we start or
Yes, you can
still
start.
wait or
We can start.
anyone can confirm? Hello. Okay. All right. So we can start, right? Okay. So
Yeah.
all right. All right. Okay. So I'll share my screen. Okay. Anyone can confirm that my screen is okay?
And good from here.
All right. So let's get started. Okay. So thanks for having me. It's quite late here and also in Singapore. I hope everybody is still doing fine and ready for some more technical and live demo. Um, it's a bit of the topic is a bit of relevant for our condition right now. Uh, Please don't expect something that going to cure COVID-19 or something like that, but it's more onto the simple projects that hopefully can you know you can extend and you can play around in order to do something about this pandemic, right? And more specifically, I will talk about Azure Custom Vision and how we can combine Azure Custom Vision with with IoT. All right, so let's get started. uh, just properly introduce myself. My name is Andri. I'm co-founder and CEO of Dicodex. uh, we are IoT and AI company in Indonesia. And I happen to be a vice chairman for Indonesia IoT Association, or we call it in Indonesia ASIOT, Asosiasi IoT Indonesia. And I'm MPP of Azure. It's been 12 years now, 12 years in a row. So yeah, I love to share. I love to contribute to community. Yeah, I can proclaim myself as a community guy, and I'm physicist by training, but I left physics long time ago. But the things that I learned from university, that we play around with electronics and hardware. Uh, yeah, I've been doing that for 20 years right now, and also for software development, and still trying to change the world through entrepreneurship kind of things. It's been 15 years now. So that's about me. So before I jump into my topics, I like to mention about this challenge. It's currently a technological challenge, meaning that you can contribute to a competition in order to detect and protect uh, around COVID-19. You can contribute to idea or projects through this website, Hackster.io, and it happens to be sponsored by UNDP. And yeah, it's not about the price or something like that, but it's more onto how we can contribute something, no matter how big or how small, in order to to do something about it, right? And I've seen some awesome projects around COVID-19 that is developed around hardware and IoT. Ventilator kind of things, oximeters, uh, to measure your oxygen level and heartbeat, for example, and connect it to internet, and hand washing, soap dispenser, something like that. So lot of funny but a lot of serious as well projects there. So I hope you guys can do can contribute as well. And we even tried to do something also about that. Started, I believe, about February. So we developed a simple project, initially simple project, right? So I can probably show you a demo. So as you can see from the demo that it able to detect face and measure the temperature around your face. So as you can see, this is still very prototype kind of things, right? And just a bit of technical about that. It's basically a microcontroller, and there is a camera and infrared sensor there, and that's it basically. You can do it standalone, but if you need to, to look at the measurement and the photo taken by the device, it should be connected to the internet. Right? So yeah, the experience is something like that. When the device detect there's a human in front of the device, because there's a infrared sensors that will able to detect body heat correctly, and also it can detect the face from the camera, and then it will measure the body temperature through the proxy temperature of your face. So that's the project. But since apparently it's becoming serious now, so we finally make a product out of it. So we call it HeatTrax. So we just launched this product, and maybe I should show you some demo of it. Just a bit of demo. So basically, you can walk around in front of the device, glance the device, and that's it. Your temperature get measured, right? And if you are the management, the building management, the office management, probably you can see the measurements, the history, and control the threshold for the normal temperature. And you can use this kind of device, for example, to detect whether the person wearing mask or not, face mask or not. So you can enforce the policy of face mask wearing. So as you can see that it will able to detect the mask, right? And the measurement still doing right, even using face mask. So that's what we've been doing. So I'm going to talk about this kind of features later to my demo, but I will go back to my slides to my topics. Let's take a look what is Internet of Things, right? So everybody, I believe, already know what is Internet of Things, but just to give you some formal definitions from ITU, for example, International Telecommunication Union. So it's basically a global infrastructure that enabling services, right, by interconnecting physical things or even virtual things. But it has to be using existing existing infrastructure, which is the internet, right? So that's the idea of IoT. So to give you high level architecture of IoT, usually it involves a collection of device, whether the same device or a few devices working together. Smart meter, smart car, for example, smart building, smart bike. A lot of this device then start collecting the data around the environment, around the physical world, and then publish those data to the internet over something like gateways. Usually, these things is connected through wireless radio communication through gateway, then publish the data to the internet, right? And in the internet, there's a backend, there's a cloud infrastructure to ingest the data, to collect the data and to store the data, and then there's some logic, to analyze and eventually to present the insight to the users, right? So that's basically the idea of IoT. So to match our demo today, I will give you just a simple example, right? So that we can talk about our demo. So for example, if I have device here, usually they call it edge as well. So for example, I have a device which obviously there should be a brain, there should be a microcontroller or microprocessor there, and this processor will receive data from sensors, be that a camera, for example. This camera is basically a sensor, right? To convert light into digital data, basically that. And for example, you get the stream of data from camera, and then you publish the data to the cloud in order to get analyzed. For example, you have video stream from the camera, right? Which is the raw data, and then using some kind of engine, some kind of intelligence engine, you can do the analysis, whatever that you want. You want to detect your face, detect whether wearing a face mask, or you want to detect the age, emotion, and gender, or probably you want to recognize who is the person is. So usually that, I mean, you publish the raw data, usually the stream frame by frame, and then you get the analysis, and then you get the engine will spit out the processing result, usually JSON probably, and then from that result, the processor on the device can process that to do whatever you want, be that displaying the result or sound the alarm, something like that. So this is just an example, right? A lot of other examples. Now, let's see if I move some tiny bit of the intelligence from the cloud, and I move that tiny bit of intelligence to the edge, right? So probably we can use it for detect the face. So instead of sending the raw data from the camera, which is frame by frame, which is a video, right? Since our use case, for example, to detect the face, why don't we do the face detection on device? Is it possible? Right? Obviously, it's possible, but depends on what kind of device, what kind of processor that you use for the device, right? Obviously, if you treat your laptop as a device, as an IT device, obviously it's very easy to do, right? You can do. Currently, it's very easy to do. But if we were talking about a microcontroller, for example, which is very low power, how you can do those kind of things, right? For example, just a simple face detection. It's not face recognition; it's just face detection. But we can do something about that. So if we move that tiny bit of intelligence to the cloud, to the edge, to the device, then instead of sending the raw data of video, then we can only send a photo, right? The photo, when a first person is detected or a human face is detected. So only that frame that you capture and then you send to the cloud, right? And in the cloud, you can do whatever you want. I mean, you can use it for. Obviously, you don't need face detection anymore because it's already done on the device. But you can use it, for example, for face recognition to recognize who is it, whether the person wearing mask or not, or classify what is the emotion, for example. And again, you can get the processing result as a JSON, and then you can display the result, or you can do action, right, with the result. So, so that combination of AI. Yeah, the cool name of machine learning is AI, right? And the combination of AI and IoT device, then we can come up with some term, we call it AIoT, right? So that's basically it. So how you can combine AI and IoT. So as simple as artificial intelligence of things. All right, so let's see what we're going to do today. I'm going to do a demo for face mask detection, which basically to detect from the camera, using the camera, whether the person detected from the camera is wearing a face mask or not. So that's the demo. So it's like a tiny bit picture of our products that I showed earlier. Right? But it's not the real way to do that because obviously I cannot share everything. But this is very obviously you can extend it to the more serious projects. So just to give you an idea of what we're going to do today is we're still using on-device intelligence to detect face. Okay, so for example, if there's a person in front of the camera and the tiny AI engine that running on top of microcontroller. Keep in mind this microcontroller. I will share later the detail about that. But this microcontroller is only 400 megahertz, 400 megahertz of processing power. So it's quite low compared to your Intel i7 8 core probably. So this is very small device, small low power. It's not Raspberry Pi though, so scratch that. So from the camera stream that retrieve from the camera sensor, you can use that tiny AI engine that to detect the face, and then obviously you can get the photo of human face, right? So we only send the image to the cloud whenever there's a face, right? And then we will use Azure Custom Vision in order to detect the face mask, in order to detect whether this person is wearing a face mask or not. So that's the idea. And then Azure Custom Vision will return a JSON, something like this. So the format will be something like this. So maybe I will zoom it just to give you an idea. So it will contain the prediction, the probability, the tag. With this tag, you can treat tag as a label, and also the most important thing is the bounding box. Where is the face? I mean, where is the mask itself within the area of the image? So later we can use this information to draw, to render where is the face, to get to draw the bounding box of the face mask. Okay, sorry. So that's the idea. And okay. And then later you can use this JSON information to render a a display which containing the box, the bounding box of the face mask if there's detected. So for that we are going to use custom vision. What is custom vision? Azure custom vision, Azure, or the more complete name is Azure Cognitive Service Custom Vision, right? So basically, you can use custom vision in order to customize your own vision model that fit perfectly with your use case. For example, our use case is detecting face mask. You can use it for example, for classification, whether within a photo, whether there's a cat or dog, for example. Uh, you can use it for any classification, or you can use it for detection. Detection meaning you can get the information where is the object, right? Instead of just knowing there's an object, but where is the object within the image? So that's what we call it object detection. So what you have to do is just upload your image, right? And then you put your label. You put your own label. Obviously, you need. This is the manual. This is the manual work, the manual labor, very laborious process. But the beauty things of a custom vision, you don't need that much of image, that many of image. I mean, obviously, if you want to train the model from scratch, you probably need million, 100,000 probably of images. But for classification, image classification and object detection using custom vision, uh, you can start training just using few image. Probably I forget. Probably under 50 image, right? So you upload your image, you put the label, and then you do training. And the training obviously is not done by you, right? It's done by the Azure custom vision itself. And then you can use it for you can start to evaluate the model, and then if you are confident enough to publish it, then you can publish it. So to give you uh, a walkthrough how to start with. I'm going to do the demo, but I'm going to walk through it to you first. Um, uh, First of all, you create your project, and then you upload your image. And for this one, I already have somebody already collect some photos there, but still I need to do my own labeling process. I have to do this, right? So I have to open an image, and then I have to draw the bounding box around the face mask. Okay. So again, you upload your image. You click one image, and then you draw the box, because we are going to do object detection, right? So we need to know we need to provide information where is the object that we want to detect within the image, and then we put our label, whatever label you want. Okay. Then after that, you can just do the train. Okay, just click one button, train, and then you can do quite quick tests. Because previously I'm using a photo, right? Photo taken by other person, but I don't use my real photo. So when I take my real photo, then the probability is quite okay. It's actually very good, very very good, right? It's 96%. So without further ado, let's do the demo. I will switch to another screen. Okay. So Okay. So this is the how you can access custom vision, right? Obviously, if you have not have an account, you can create trial account from Azure trial. So after login, we will have our project list. And you click that. Okay. And just to show you to add your data set, you can upload your photo. You upload. Okay, and then after that you do the labeling. So I draw something like this, and I put the tag or label, and that's it. And it will goes to the workspace, and then after that you can do the training. Right? I'm not going to do that because it will take quite some time. It's about 30 minutes. And then if you already have done training, and you will have uh, several iterations depends on how many times you click the train button, right? And if you are happy with every iteration, you can select which one that you want to publish, right? So each iteration represent your model, basically your vision model. Okay. So for example, if we want to use this, then we can get the prediction URL, right? And yeah, you can get the image URL that you can use to post or publish the image, and that's it. Then later you can use whatever HTTP client or HTTP library that you can use uh, with your development platform, right? So uh, I'd like to know how many times that we still have. 20 minutes, 30 minutes? Anyone still listening?
We have about 25 minutes, Andri.
25.
Yeah.
All right. Okay, so now I'm going to switch to my sorry. I will switch to my my camera here. So over here I have the device, right? I mean the microcontroller and everything. So as you guys can see that the device is something like this. It has camera. So camera over here. It has display, and it has Wi-Fi, obviously. Okay, so I will use this URL to get the prediction of my face, right? Whether I'm wearing face mask or not. But for that, well, previously I like to sorry, I like to show you the just a simple code, right? Well, it's not really simple though. So over here I'm using a IDE called C Lion in order to write the code with C++. And I happen to use Arduino framework. So Arduino, as you know, Arduino is not it's not only the hardware or electronic boards, but it's also a framework, a software framework, basically that you can use it for uh, for sorry, developing your application for a microcontroller. So what I'm going to show here is that first thing first, I want to make sure that the face detection of the device is working, right? Okay, as you can see, currently it's already working, but I just like to make sure that. So from this code, it's basically you just initialize the LCD, the display. Okay, the display, and then okay, then you init your camera, the camera over here, and you do the face detection. So over here I have a class that I have written before. So it's like, yeah, a lot of functionality basically encapsulated within this class, right? In order to to initialize the model and to do the actual face detection. So we're not going to going through all of that. And this is so after that you can upload the code. Okay. So currently I'm uploading the code to the device. As you can see, it start to blank. And what I want to show you is that the device is able to pick up my face, obviously, and then it will try to determine whether I'm close enough to the device or too far away, because probably we want to make sure that the photo taken is quite okay. I mean, if too far away, obviously the object will be small, right? So as you can see that if I move too far away, then it will tell me to move closer, and then if I move closer, then it will display something, right? This is actually just probability of my face, right? The detection probability, and I need to write some event handler to know that whether the face is entering or exiting, right? So for example, if I like entering, phase 0 is entered, and then if I go away, then phase 0 is exiting. Right. This is very important so that we don't do the the detection very often, right? So we need to come up with some kind of timing there. All right. So now to show you the actual demo here, I'm going to edit just some one line of code there, and we'll try to let's re-upload the code. Okay. I'm not sure why my computer is a bit slow today. Okay, now it's uploading already, and now as you can see here from the demo, from the display, the device is starting to connecting to Wi-Fi right now because I activate the demo, the custom vision demo. All right. So as you can see that when let's try again. So when my face is exiting, then when I'm entering, and then okay. So previously, I'm not sure why. Previous. Let's turn it off first. It should be faster though. Usually the demo working well. Okay. So as you can see, when I enter previously, it will start to publish, to post the data to the photo to Azure Custom Vision, right? Let's maybe we can try again. After it's, I'm not sure why it's not failing. Okay. Before the demo, I tried this many times. But, yeah. Okay, let's try again. So when I start to move closer, it will pick up my image and then start to upload the JPEG version of the image to Azure Custom Vision. But apparently, I don't get the result. I'm not sure why. So let's continue with the slide. Right, later I will go back to the demo. So basically, what I want to show you that right after the response retrieve from the Azure Custom Vision, we can start to draw something on the display, right? Okay. Okay. So back to our slide here. By the way, yeah. Again, this is the actual device that I've been using, right? Okay. So the great thing about this Azure Custom Vision is that all the image that you publish is actually get grouped into a collection of images that have not been training, that you can reuse your task image or your inference image for the next training, right? So as you can see here from the prediction, so depends on which iteration that I'm using. So basically, any image that get published, that is used for inference, will be collect grouping here, will be put together here, and obviously you can use it for next training, right? For example, this one, right? You can be sure that there's a face mask here, and you can do the adjustment, or you can accept whatever it is, and then after you close, then it will goes away from it will go away from here, and then it will be added to the training set. I mean, so to the data set. This one, right? This guy. Okay. So again, let's see another. So for example, obviously this guy is not using face mask. So as you can see that there's no detection here, right? Or if there is a prediction, then there is a very low probability, which is 20% is not accepted, right? Okay. And this funny thing is that if I'm using my hand to cover my mouth, right, like this one, it's not recognized as a face mask though. So it's quite clever there. Okay. Okay. Let's try again. Let's try again demo. All right. Okay. Okay. As you can see that there's it able to be sure that I'm not wearing mask right now. Let's try again. So processing. Sorry guys, there's still a bug here. Okay, let's restart the device. There's still there's a memory leak here, I believe. That's the hard part using C++, right? You have to manage your memory by yourself. Okay, as you can see that now it's able to pick up that I'm not wearing mask. Then if I'm using mask, okay, and I am entering the scene. Oh no. Oh, sorry guys. There's still bugs there. Let's try one more time, right? Let's try one more time. Okay. So as you can see that it able to detect my mask right over there, and the confidence level is quite high there. It's about 99%. Well, it's quite high. Okay, let's change into another masker. Okay, it's still able to pick up my face mask. And the funny thing is that if I'm using my hand to cover my mouth, right? Okay, so as you can see that it said I'm not wearing mask because I'm covering my hand. And same thing if I'm using my shirt. Okay, same using my shirt to cover my mouth. Still same happen, right? Not wearing mask. So it's not only something that cover your mouth or your nose, right? But it has to be something that recognized as something like face mask. So as you can see, the demo is working, thankfully. All right, so to close this presentation, sorry, I'm switching to another screen again. So the big question is that whether is it possible to do all detection, which is the face detection and the face mask detection on device instead of face detection on device and then the face mask on the cloud, right? Yeah, obviously it's very visible. That's what we're doing with our products, right? But it will beat the purpose of my demo, which is using Azure Custom Vision. So yeah, obviously I have to use detection on the face mask detection has to be on the cloud on Azure Custom Vision side, right? So that's there you have it, the demo. And to know some more about Custom Vision, obviously you can go to customvision.ai. But if you want to create your own model from scratch, yeah, obviously you can use Azure Machine Learning Services, right? AzureML.com. And the device or the hardware that I just use is it's called Scipit Mix. It's called Mix makes glue. It's developed by a company called Saipit. You can get it. I'm not affiliated in any way with them, so this is the free advertising for them. You can go get it to this website, and if you want to know more about our product, the face mask detection and body temperature measurement, you can go to this link. It tracks, and the code will be uploaded to my GitHub, obviously, over here, and the slide also will be published to my slideshare. So I will update to Satish to get you the actual link. And if you like to know more about IoT and AI, especially using related to Azure services, we can arrange some kind of mini series to do something like Azure IoT Hub or Azure IoT Central, which is turnkey solution for IoT using Azure. And if you want to combine IoT with AI, you can use Azure Custom Services, which is there are many other services besides just custom vision, right? There's a face API, there's speech API, something like that. So we can do some kind of mini series to talk about that, to discuss about that, if you guys interested. And even we can go deeper, to take a look and get on the Azure machine learning services. All right, so that's from me. Anyone want to put AI on IoT? Let me know. All right, thanks.
Thanks, Andri. Thanks for that wonderful session. Any question for Andri from the attendees?
So I saw on the chat, right? I saw on the chat there's for HitTrax product, does it use higher resolution camera than the demo? Yes and no. It depends on your use cases, right? So for example, for our use case, for measuring body temperature based, the scenario is one by one basis, meaning so probably before you enter the gate or the access door, you need to get screened first. You need to get measured first. Then you don't need, and you have to be close, right, with the device, right, because you want the one that I'm using is actually the board itself, right? Yeah. So it's not something that that come up with a packaging, nice packaging, enclosure kind of things. So it's the original form is like that, right? So you buy like that. So you have to be quite careful with your hands quite get wet or something like that. But when you get used to it, and then it's not a problem. Right. So it's because this kind of device is actually a what we call a development board. So development boards means you use that for prototyping kind of things. You can do whatever you want, right? So that's why there's no warranty on this kind of device because it may break.
Okay, thanks.
Yeah.
Any other question, guys?
The internet is not available, then the AI will not working, right? So how will we solve this?
I'm not sure I catch that. Could you?
No, I think it depends on the connection to the to the service for the detections. So if the internet is not working, so what will happen? Is there any offline mode or based on the previous history?
Yeah, that's a very good question. Thanks. So obviously, Internet of Things, the keyword is the internet, right? So depends on your use case, whether what kind of quality of the internet that you require. I mean, I think that's what my take on that. So for our use case, right? Because we want to be able to send some picture, even though the photo or the image is quite small, which is about 4 kilobyte. It's nothing for our internet right now, right? But sometimes again, there's some glitch, there's some problem. So, like you said, I mean, you need to have some kind of storing, for example. You need to have some mechanism of storing locally. That's why usually this kind of device they have several megabytes of storage, which is small for compared to our laptop. But for this kind of device, because the cost is quite low, the storage few megabytes, I believe this one is about 16 megabyte. It's quite enough for storing locally temporarily, right? And then you do the publishing again when there's no connection. But like I said earlier, can you do the detection locally, all the detection, not only the face detection, but also the face mask detection or any kind of detection that you want? Can you do that on device itself without requiring any cloud whatsoever? Yes, you can. Right. What you need to do is you optimize your AI model, your ML model, and you do some kind of compression. Maybe that's for another topics, but just give you an idea, right? So it involves all kind of uh, model conversion. So you need to convert the model. You need to optimize the ML model so that the size of the model would be very very small to fit into the storage and the memory or RAM of the device, right? Because, for example, when you're talking about YOLO, for example, YOLO model for object detection, it can come up. It can be few megabytes, right? The model size. So that's why you need to optimize that. There's a lot of tools for that, and so that you can compress the model size into few kilobytes, and then you put into the device storage, and hopefully it will works. If you create your own model, you even can fine tune from the early on, because usually there's two way of optimization. You can do post training after training, so the model is already there. You can do something like quantization. That's what they call it, to minimize, to compress the size. Or if you create your own model from scratch, it's even easier. I mean, it's even flexible. Right? You can start to do the optimization, the number of the layers, the number of the number and the depth of the layers. Right? You can adjust with that, and you can use uh, for example, integer 8 instead of float, for example, something like that. A lot of theory behind that. I'm not that good on that, right? But I have my own practice. But that's basically that's the idea, right? You compress the model and you put the device. So not all, maybe most uh, of the model, or ML model that we see that currently running on the bigger machine or on the cloud, we can start to bring those models to the smaller devices, right? So obviously that's the idea, to bring everything running on the device, or they call it AI at the edge, right? Or edge AI. That's the buzzwords. That's the mission there, right? So that you don't really need the connectivity. You only need connectivity in order to publish the processing result, right? The structured data instead of the raw data, so that you can still to do the heavy lifting, the analytics on the cloud, right? that's my take on that.
Thank you.
All right.
Okay, I think again we are on the dot here. So thanks, Andri. Thanks for this
All right.
wonderful session. Thanks for
Thanks
taking
for the
time.
opportunity. Yeah.
Yeah,
Have a nice
I hope
day.
we'll have more
Night.
opportunities to have this kind of sharing sessions in future.
Sure.
Yeah, thank you. I would like to share
Yeah.
a couple of updates. So if I can just share my screen, just a couple of minutes. In the month of June, we have a couple more meetups happening. In fact, tomorrow we have one which we are co-hosting with the Java user group or JUG in Singapore, and we have Josh Long who is doing Beautiful Azure. If you are a Spring fan and if you are working with Spring Boot and Spring Framework, this might be a good opportunity for you to understand how you can migrate your applications from on-premise to Spring Cloud on Azure. So that's happening early morning tomorrow at 8 a.m. Singapore time. And next week we have another meetup, which is with a guy called Thomas Marer. He's a part of the engineering team in Azure. He's cloud developer advocate. He'll be talking about hybrid cloud server management using Azure Arc. So these are upcoming meetups which we have for our group. I hope you will find them useful and you will join us for these meetups. So thank you all for joining and have a nice day ahead.
All right. Bye.
Bye-bye.
Bye bye. Thank you.